Finding expectation by conditioning is just a restatement of an idea you've had for a while. If there's a class of students and I tell you their section averages, so say they have these 3 sections and there's the section averages, and I ask you what was the average of the class, then you're going to look at the section sizes and I hope you're going to do the following calculation. You're going to take the weighted average of the section averages, where the weights are the class sizes, the section sizes. And if you run that, you will get about 76. But the point is that you've taken these group averages and you've averaged them. So you've averaged averages. And we will do that to find unconditional expectations by looking at conditional expectations and averaging those. So here's a joint distribution that I made up, and we're going to try to find the expectation of the random variable t, whose distribution is given here below. So the chance that it's 3 is 0.6 and the chance that it's 4 is 0.4. So you can find the expectation of t from that distribution by doing the obvious thing. You can also extremely laboriously find the expectation of t by going cell by cell in the joint distribution table. So t is 3 here, so 3 times 0.1 plus 3 times 0.2 plus 3 times 0.3 and then 4 times 0.1, 4 times 0.2 and 4 times 0.1 again, and that's this calculation here, which gives you the same 3.4. But now you can also do it by conditioning on s. So if you look at the event s equals 7, then given that, the chance that t is 3 is 0.75, and the chance that t is 4 is 0.25. This is the conditional distribution of t given s equals 7. So also the conditional distribution of t given s equals 6 and given s equals 5. Now these are distributions in their own right. So 3 with this chance, 4 with this chance. That's a distribution. It has an expectation. That expectation happens to be 3.25. 3 times 0.75 plus 4 times 0.25. This distribution, 3 and 4 with chance 0.5 each, clearly the expectation is halfway in between, 3.5. So each of these conditional distributions has its own expectation. These are called conditional expectations given the particular value of s. And at the bottom here, you have the unconditional expectation, the 3.4 that we calculated in a couple of ways, and the unconditional distribution of t. So we understand each row, but surely there has to be a relation between this unconditional 3.4 and these conditional 3.5, 3.5, and 3.25. This 3.4 looks like it's some kind of average of these 3 numbers. What kind of average? Clearly a weighted average. And what are the weights? The weights are the probabilities of what you're given, which is the marginal of s, the distribution of s, the chance that s is 5, the chance that s is 6, the chance that s is 7. It's right here, 0.2, 0.4, and 0.4. Those are the weights that you attach to these to get your unconditional average. So let's try that. This 3.5 gets multiplied by this 0.2 is being weighted by the chance of the given condition s equals 5. And then this 3.5 by this 0.4 and this 3.25 times this other 0.4. And if we run that calculation, then you get the unconditional mean 3.4. So you have once again taken the average of the group averages. If you write that out cleanly as a table, then you notice something. For every given value of s, you have this group mean. In other words, you have a function of s. And you have here the distribution of s. You know how to take the expectation of a function of s value times probability, etc. And if you do that calculation, that is, you multiply this column by this column, you get the unconditional expectation. So something wonderful has happened here, and we're now going to formalize it.